All right, let's take a look at the two questions that you'd asked about. So number 16 says that we have a function, it's differentiable. Values of the derivative are given in the table, and it asks which of the following must be true. Now, the biggest misconception on this one is people make assumptions about what happens between 0 and 2, between 2 and 3, between 3 and 5, where the reality is the graph could oscillate like crazy between those values and bounce up and down and have all kinds of mins and maxes between. All right, so we got to be really careful about what we're assuming at each of these values. So A says f is increasing on the interval 0 to 2. All right, now the initial velocity is positive, the ending velocity is 0, but nothing stops it from being negative at some point in the middle, so this one's out. B, it says f is decreasing on the interval 0 to 2. Same issue happens there. All right, the graph could oscillate wildly between those two values. We just know the slope at 0 and we know the slope at 2. All right, then it says f has a local maximum at x equals 2. All right, so if I just zoom in on this one value, now the reality is I have no idea what sign it is immediately before that and immediately after that. So I can't really identify maxes and mins. A lot of people make the kind of mistake of taking a look at that 5 and negative 2 and saying, oh, it goes from positive to negative, so therefore it's a maximum. But again, between that first spot where it's positive and the spot where it's 0, we could have all kinds of things happen with that. All right, so both of these are out for that reason because we don't know what happens immediately on each side. The last one says f has at least one local minimum on the interval from 2 to 5. So if I look 2 to 5 out here, we'll notice that the velocity goes from positive to negative at some point between 0 and between 2 and 3. All right, so that would be a maximum relative. And then somewhere between 3 and 5, it goes from negative to positive at least once. So that would be decreasing to increasing, so that would be a local minimum. All right, so our correct answer on this one is E. All right, now 20 was the other one. So if I take a look at 20, 20 says a particle moves on the x-axis, such as graphs given above. And that's a graph of its velocity. And it says for what values of t is the acceleration of the particle increasing? All right, so v of t is velocity. All right, so v prime of t, the derivative of that graph, would be acceleration. All right, and then v double prime of t would be change in acceleration. So we need v double prime of t to be greater than 0 for acceleration to be increasing. All right, because the acceleration's increasing when the rate of change of acceleration is positive. All right, so v double prime, that corresponds with concavity, and I want it positive, so we really want concave up. All right, so concave up, that would correspond with the first sections here from 0 to 2. All right, so our correct answer would be A, 0 to 2, because through that whole time, the slope starts at a relatively steep negative, goes to a 0, and then progresses to a positive. So that whole time, the acceleration, right, is increasing because the slopes on the velocity graph correspond to acceleration. So the acceleration starts at a steep negative, then it goes to 0, then it goes to a steep positive over that section. And if I kept going, then it would start leveling back out towards 0. So we're looking at 0 to 2. All right, hope that helps.